Modern atomic theory, relative atomic mass, as translated from Mr. Salter's lecture. Essential questions. How does a mass spectrometer work? How do I use mass spectrometer data to calculate the relative atomic mass? How were the masses on the periodic table determined? First of all, you need to know that a mass spectrometer is used to measure the masses of the different isotopes and the relative abundance. With this data, we can calculate the relative atomic mass, which will be defined later. There are 5 steps to the basic operation of a mass spectrometer. Step 1 is vaporization, where the atoms are converted into a gaseous state. Step 2 is ionization, where the isotopes of our elements lose electrons from their atomose shell and become positively charged. To do this, the atoms are hit with high-energy electrons. This step can be summed up with the equation X gas plus an electron equals positive X, or ionized X, plus 2 electrons. The 2 electrons at the end are the electron you fired and the electron that was knocked off. The third step is acceleration, which occurs when the positively charged ions are attracted to negatively charged plates, causing them to accelerate. Step 4, deflection, is when the different elements of the isotope are separated by deflection, which is proportional to the charge-mass ratio. So, the smaller ions will be deflected more than the heavier ions, and ions with higher charge are deflected more than ions with lower charge. The final step, detection, occurs when the charge-mass ratio is detected and a signal is sent to a recorder. The recorder then creates a graph showing the mass charge and percent abundance, called a mass spectrum. Now, we use those results to find the relative atomic mass, which is the average mass of an atom of the element, taking into account all its isotopes and the relative abundance, compared to one atom of carbon-12. Carbon-12 is used because it is very common, it's easy to store, it's solid, and it has a relative mass of exactly 12.000 AMUs, AMUs being atomic mass units. Please refer to the graph on your notes. I apologize, but I don't know where to find that to put it on the slideshow. On the x-axis of a mass spectrum, you will always see the mass-charge ratio. On the y-axis is the percent abundance. On our graph, we see magnesium and its 3 isotopes, magnesium-24, magnesium-25, and magnesium-26, at their different levels of abundance in nature. The table above that gives you the same basic data. Now, to calculate the relative atomic mass of magnesium, you need the atomic mass from your periodic table, which is 24.32 AMUs. You first multiply the atomic mass of each isotope, 24, 25, and 26, by their respective percentages. Next, add your 3 products together and divide that number by 100, because these are based off percentages. Your final product should match the relative atomic mass from the atomic table. And that is how you calculate the relative atomic mass of an atom.